some real world application and where they might give us some story problems working with those square roots. So it says the distance in nautical miles you can see with a periscope is 1.17 times the square root of the height, where the h is the height of the periscope above the water. Can a periscope that is 6 feet above water see twice as far as a periscope that is 3 feet above the water? Explain. So I put in here, go ahead and use your calculators to do the distances. So we're going to go ahead and use this equation for both of these. So for the first one, where h is, we're going to substitute a 3. So 1.17 times the square root of 3. And then for our other one, it's still 1.17 times the square root of 6. Okay, so when you solve these, you have to do your square roots first. And we're going to go ahead and actually get the actual answer. Okay, so the square root of 3 is 1.7, a really long number. And then we're going to take that times 1.17. And when I do that, I get 2.026. Okay, so now I'll go ahead and do this one. So I need to do the square root of 6 times 1.17. And when I do that, I get 2.865. Okay, so the question was asking, can the periscope that is 6 feet above water see twice as far? Is this doubled to get our 2.865? No, so that would be a no. Why? Well, because it only sees, what, about 0.8 nautical miles further. Okay, so no, it did not double it. Okay. Last question. It says you use a periscope that is 10 feet above the water. Can you see farther than 4 nautical miles? So here we're checking to see, will it see further? So what's your guess based on the fact that we were at like 2.87 approximately for 6 feet? So do you think at 10 feet that it will? Well, let's go through and check it. So we're going to plug in 10 here. So we're going to do the square root of 10 times 1.17. And when I do that, I get 3.69. Repeating, or about 3.7. So can it see farther than 4 nautical miles? No, it's still only a little above 3.5 miles. So that's it for this lesson, working with approximating roots, and then also working with some non-perfect roots. Key thing to remember here is that when you're working your way, your way with approximating, make sure that you work with those perfect squares and finding those 2 consecutive numbers that it falls between. I know that that's something that is showing up on STAR, so I want you to get comfortable with those.